computer. Okay. All right. So let me see if I can share my screen here. Okay. Can people see the screen? Yeah. Good.
Yeah.
Okay. All right. So today, yeah, we're going to do a little bit of an introduction to Python. I don't think the Data Week series, or really at anyone at CETA has ever really done this before. So this is completely new kind of stuff. So during this talk, feel free to interrupt, ask questions if you want to add them in the chat. I think I have it opened good enough where I can capture it as it comes on. Yep, just feel free to interrupt. Um, so I guess maybe a little bit about the whole agenda. So I have a few slides prepared, basically trying to give a little bit of sense of like what the Python ecosystem is. And then a really kind of, because this is what like a lot of people have like in that I've talked to around Anschutz is like really like how does it compare to R? Why would I ever use it if I already use R or SAS or something like that? I don't have any really experience in SAS. So I was going to talk about you really like kind of really try to compare to R. And then there's like I have like a tutorial that we'll walk through that goes through some code. So I guess a little bit about myself, I guess before we get in this, like why do I know Python? Um, so I have a PhD in physics. So I did a whole bunch, that's what I did for quite a while. And basically people that I knew either coded in MATLAB or physics. That was like those are like the engineering physicsy kind of languages. Unless you're getting really into coding and doing like C++ and or stuff like that. Um, so that's why I started coding when I was in physics, and then I moved around a little bit, family situations and stuff, and then I ended up doing computational biology in a lab that, luckily enough, they were using both Python and R. So I kind of got a lot of experience doing coding in both. But so basically, I really did know starting to learn Python because of like my physics background. And I've been doing it for about 10, like over 10 years. Okay. So the high level comparison between R and Python, like what do they share in common? So they're both open source programming languages. That means you don't have to pay any money to use them. They're free to download. The code, in theory, for every single package, every single thing you run should be openly, freely available online for you to see what is going on. This differs for packages, like MATLAB, where you pay for it. And if you want to see how an algorithm runs, you can't really actually do it. So to me, it's really for science purposes. I really like the fact that, the open source languages. So that's kind of where I try to live in. They're all platform independent. So it means you can run them on Windows, Macs, Linux, both. And, for this, community, they're both very suitable for biomedical data analysis. So what we'll see throughout this talk is that they have many, many more similarities than they do differences. And because they're both really like high level syntax languages. They're not incredibly, as programming goes, they're relatively easy to use. Now, programming in and of itself could be very difficult for if you're for in any language for anyone, but in the scheme of like computer science languages, like, coding in Python or R is much easier than coding stuff in CUDA to, manipulate stuff on GPUs, and for instance. But these are both really high level, easy to use languages, and they're very well documented, and they both have lots of tutorials. So basically, where does the split happen? Like what is um sorry, there's a lot of I don't usually get these like admit things, and I think they take over like here for a second.
Don't worry about it. I will admit people.
Okay, all right. Great. So like where do they really come down to like the differences? There's some slight differences on like the basic uses of what they were designed for. Python is like really general use language. It really is designed to be of one tool fits all problems kind of language. Whereas R was really designed with statistics in mind. and like looking at data, and then with that closely followed data visualization. Now, there's these two subtle things that I'm just going to mention here, but I don't really expect many people, if people have questions about this later, we can talk about it. But there is like a fundamental how do I program things that we will see a little bit in the tutorial about. R is really about functions. So a user will define a function, and then you call functions, and then your data, just uses a bunch of functions. Now, Python is really designed for classes. So you create kind of like this object, and inside of that object can live functions, but it can live other things like assigning different names and data types, variables, and this all lives inside an object. So you don't necessarily call functions that people write directly on these things. You just use this object and then you call functions from it. It's a little bit different, and but basically, you can write Python code in functional programming. Like you can just use functions in programming in Python. And in R, people have classes now. Like you can download, like if you do basically anything in single cell, everything that you do gets put into a class at this point. They're not inherent in the language. You have to like download extra packages to do them. But like people now have doing, so again, it's like, again, pretty similar. All right. So installing basically R and Python. Now, R, you go to the R website. That is a thing. Then you download your R project. And then you go to the R project and you click download R, and then R goes onto your computer. And then you select something called a crayon mirror to see where you want to download other packages from. But the idea is you go to the R website to download it. Python has many ways you can download it. The easiest way at this point for data science is to download something from anaconda.com. I mention this because it's not obvious that you don't go to www.python.com to download Python. Um, a lot of people just use this Anaconda environment, and basically what you can do is you can download Python and thousands of packages all at once. So it'll include all your data manipulation packages and all these things, and it's all just lives in one big, 7 GB file. Um, Now, sometimes this is a bit large, but you can still use Conda, and you do something called mini Conda. And Conda is also huge. You can actually download R in Conda. But like the idea is it's like you don't just go to www.python.com. Maybe you can. I don't know. I actually even looked at it or tried that in a while, but I just don't know anyone who ever does that to download Python. And I mentioned these steps because this is a huge barrier sometimes of even using a language if you get confused about how to install it. But I just want to mention these are not trivial steps sometimes. Like getting a programming language to work in an easy way on your computer is something that people struggle with. And it is very hard sometimes to get it to actually work. So I just want to, these aren't like trivial steps even to just install it. They're actually sometimes the most difficult steps to do. Okay. So along those lines, what is, so there's like, like different coding. So, part of like the ecosystem of like, Python, when would you use Python? Why, if people use R, why would you ever use R? Things that are called the integrated development environments are basically how a lot of people code. So what you do is you have these applications or GUIs or whatever, however people want to think about them. But they allow you to see your code in certain ways. They'll highlight, they'll autocomplete, they'll have like GitHub for people to know integration built into that. You'll be able to use your, desktop files. You'll see variables in a certain column. So basically, like the way that you sit in front of your computer and code is very important. And for the longest time when I used Python like 10 years ago, there was like not really that great of stuff. There was basically Python people coded in Visual Studio, but a lot of people just coded in scripts. Like everything was in scripts. And R Studio came along, and people would never, this was one of the biggest barriers of why people who wanted to do R wouldn't go to Python. It's because there was nothing like RStudio, really. There was nothing that you could use that was like all encompassing and very easy to use and see what your code is doing and what the outputs are. That has now changed recently, and now like Jupyter has like a Jupyter Lab that which is what we'll use. Um, but in general, there's these things again once became like again like a couple of years ago, our studio was far superior, I think, to like almost anything a normal person would use, except if you wanted to go into the Visual Studio Code section. But like, like now, but people like there's all kinds of IDEs for Python. And so yeah, so now like, so they're basically, again, both very easily. And so for Python, you can use Jupyter or Visual Studio, but R Studio is still just for R. Um, and and also now you can have like browser versions of these things. So you don't even actually need to use your actual computer hardware. You can like just log into an account and then RStudio will just be there and you can use like their other people's like hardware to run your code. Okay, so then installing packages. So the ecosystem of R versus Python. So when you do R, there's something called a comprehensive R archive network. And this is where people's packages live that are just ubiquitous. That you use this is like I think like the general purpose package thing for R. And that equivalent in Python is called the Python package index, or you pip install something, or PYPI. Um, so they're basically, each of these languages then have like a place where people put packages that are like good, well formatted in a certain guideline kind of code. But then R, where R is much different, is that R really has a whole entire ecosystem called bioconductor. And so this is really kind of where these things start separating, is basically like which packages can you use. And so bioconductor is home to just really great bioinformatics packages, and you can go on there, you can browse them, you can see them. Um, Now Python, you can con has a conda installing, so there's like a whole package managing system, and there is something called bioconda that people have recently been trying to put a bunch of Python bio packages in. Um, but it's not nearly as good as Bioconductor. But there are some packages that you can find in Conda that you can't just find on regular pip install. Yeah, so you can download Python probably. I just see this like you can go to Python download. There is just like yeah, I mean, you could do it. I mean, and also Macs come with, Macs and Linux systems come with Python pre-installed, which is different than, like I don't think Windows machines necessarily come with Python pre-installed. So there are different ways I think you can get it. I've just never really heard of anyone just going to python.net to install it in like the last, I don't know, in 10 years I've been doing it. But then again, all of this, what I'm saying is just sort of my experience of Python. Um, and like, yeah, so it's like an incredibly popular language. So there's millions of ways to do everything. Just like I'm sure that you can go into install R in like, a bunch of different ways that I don't know how either. And
Chris,
then
there's
you
a
also,
question. Sorry, there was a question in the chat. Can people download Python from www.python.org/download/release/Python?
yeah,
Okay.
yeah, yeah. So I guess that is I was just trying to address that a little bit. That you can download, probably from Python, and then you can do it. Then you get into a little bit of a different, yeah. I mean, you can. I guess you can. I don't know really people who do it that way. I haven't heard of anyone really doing it. I'm sure people do. I'm sure there's people who don't do. I mean, everyone I know who does this now is like doing data science. And so you download Anaconda because it has all the packages and package manager because you're going to need dozens of packages to do any kind of project that you want. But there are things that you can download, just the bare minimum Python and download, only the exact package that you possibly need. And a lot of these times, these are people who are deploying Python on apps because it's very um, general purpose language. So a lot of times, like, when you're in a company and you're trying to deploy things on like millions of devices and stuff, you need, like the difference of having something be like 40 kilobytes versus 80 kilobytes, could be very expensive or time consuming over the end. So there's different ways that people download it. I'm going more for like the data science way of downloading Python.
And is it okay if I ask a question just to
Sure.
add on to that? Um, so my understanding of this is that with R, you essentially just download individual packages. And with this Anaconda, I'm just looking at this right now. So like the free download of the distribution of these other packages, it's all inclusive instead of having to download those packages individually within Python. Is that my understanding?
Yes. Yeah. So yeah, it's like, it's yes. So kind of will come, yeah, so kind of will come with all of the like these packages. So when you're in your base Anaconda profile, you can have access to like machine learning packages, all the data.
Okay,
Like in R, if you download just R, like even if you want to use tidyverse, which is like, this hugely
right,
popular package, like you have to install tidyverse.
right. Individually. Yeah, right.
So yeah,
Okay,
so
that
there's
clarifies
like a
things.
shortcut way to do it. But again, like people were saying, you can just install Python and then install things as well, just the same as R.
Sure.
I just like the Anaconda prepackaged
That makes
everything.
sense.
Yeah,
Thank you.
you're welcome. All right. All right. So then again, for people who are using R and they want to go into Python or maybe vice versa, like what are the major things that I think that people kind of use that are very similar in both languages. Um, and so when you're doing, biomedical data analysis, the first thing you need to do is handle data. And so base R is in fact incredible at doing this. Like it's like it has all these functions. I forget, like forget they're called Tibbles, right? Like, however, I haven't actually used base R in quite a while to do some of this stuff, but like it was amazing on its own right to do data analysis. Building data frames, manipulating them, loading Excel files. And Python was not. Python had nothing basically at all. Like you had to read a Excel file in, like, a CSV file in line by line and build stuff up yourself. And then so basically R was really good. And then while that was going on, then when Python started getting to use more and more for data science, people then really built an ecosystem out called pandas. So, and then tidyverse was just like taking already what was pretty good and then making it, in my opinion, like even better. Like tidyverse, you can like manipulate data in such an easy, intuitive way. Like it's just amazing. And basically what pandas now is I feel like it's more like, it's like base R at this point. It's like you can do some good stuff in it. You can get the job done, but tidyverse is just like so sleek and like nice. So like if you're just doing, data handling, again, you probably just use R, but there is pandas out there for people who do need to look at data, and pandas, gets most of the stuff done. There's very little that you can't do in pandas that you actually want to do. It just might take a little bit more effort. And then there's data visualization tools. So again, for a while, like, R designed for stats and then data. And with that closely follows is I want to look at the stuff. So ggplot and visualizations were like amazing in R. And then you can do all these kind of cool plots because the data was in a data frame in a certain way. And you could just make really excellent plots. And then matplotlib was pretty good. Like it was pretty good. But then basically what happened is Python tried to copy-ish, ggplot. They actually have now fully copied ggplot. There's like a ggplot Python version. So, but then Seaborn came out. So now they're both kind of like equivalent. I feel like in either language, you can make any kind of plot that you really want to make. There's no, but like again, it was like which one was following the other. And then machine learning, they both do machine learning. It's just that scikit-learn for the longest time was like the reason I ever heard about why people would do Python over R. It was like if you wanted to do machine learning, it was done, you did it in Python. It was okay to do in R. You know, there's lots of stuff in R, but it was like this really huge, nice ecosystem with hundreds of functions that all played very nicely with each other and like manipulating the data, finding splits for training. It was just really nice. But then again, R has some things. They have like, it's kind of like a mixed bag in R now. That's why there's not one. There's like a couple that are kind of competing for each other. I really like tidy models myself. Like it's it's like kind of like the tidyverse thing, but then also like, you know, for machine learning models. And then another thing that's very interesting about R, like, and this is just to bring up the point that they're both very similar. So like some of this is like the beginning point here is if you have R, if you're doing R and you want to get into Python, it's not like don't think of it as like a super huge jump. There's syntax error, you know, like things and stuff like that, and it's kind of, you know, daunting to go into another language, but they are very similar. In fact, each of them have a package where you can just run other code, like Python code in your thing. So if you actually mostly code in R, but you need to do something with Python, each of them have a thing, a way of running Python code, or R code in the other one. And they work very nicely. I tried them a few years ago and it was not very, like, it wasn't that great of an experience, but I have tried them recently and they're good. Like, so like if you, at this point, I guess my thought of this is like an intro to Python. Like if you want to get into Python and you know R, you might not actually have to just like abandon R. You can just incorporate Python into your coding environment, and just run whatever you need to run in Python, in R. Okay, so I guess why then would you use one over the other? The biggest thing is packages. It's like someone else has already written something that does something complicated that you do not want to write yourself, that answers a question that you need to have answered, but it's in a different language. That is really solely the only reason that you would ever, if you're an R coder, ever switch to Python, or if you're a Python coder, you'd ever switch to R. If it's going to be some kind of like function that you're going to write yourself, it doesn't matter what language you write it in. They're both equivalent. You just pick the language you're stronger in. It's mostly like when you go to do something and there's not a package that supports what you want to do. And so some examples of that are, like people who do single cell gene expression and analysis. You can use Seurat and R to get a lot done, and then you can use ScanPy and Python to do a lot. And so they're like kind of equivalent where you do the basic things, but then there's all these like newer methods that use deep learning to like find information out about the data. And those almost exclusively are in Python. So people who have been coding for the last handful of years in R to do a single cell analysis, some of these like really big packages that I have found, like some of the ones, more popular ones that I like, they're only in Python. And some of this reason is that like Python is really good at deep learning. It is that like this is where still if you want to do something and you're gonna possibly run it to do something and you because if you're doing a lot of data science, where you run into I want to do something is deep learning. Like I want to run a neural network that is, a general adversarial neural network that, I need to train this from stuff. Like you're gonna probably have to go into Python. Like as far as I know, R has a little bit. I think there's like the Keras package, is both in Python and R. But for instance, like many people write in PyTorch now, PyTorch or TensorFlow, but PyTorch is like predominantly like kind of like to me, like the bigger deep learning language now. And it's like, I think exclusively in Python, as in its name, PyTorch. Um, But for R, there are so like, because I coded almost exclusively in Python when I was building computational models as part of my like methods development work. But then as I transitioned into CETA and I needed to just analyze people's data, like do differential expression, gene set enrichment analysis, there were some packages that you could get done, do this in R, Python, but the R ecosystem, it was just incredible. And like all the tutorials I saw were in this, all the help questions, if I wanted to do this, came back like how to do this in R. And it just made way more sense to use, a package in R that's cited 50,000 times as opposed to like, the Python package that was created 2 years ago to try to copy it. So I just switched because it's just like if you're doing biostats in general, like R has by far the better packages and is much more well documented. But then going back to Python, another reason that people might run into like I need to use Python, this is a bit more niche, but like cloud computing. If people want to interact with on the cloud with devices on the cloud and like spinning up virtual machines and running code on the cloud, most cloud infrastructures support some kind of Python toolkit where you can, save data to the cloud, read data from the cloud, do all this kind of stuff in Python. But they do not for R. So there is like no kind of R support at all for any of that. Um, and so just in general for Python, this is the intro to Python class. Um, what I find Python is actually better at is error handling. Like it's really great. It tells you like the very specific types of errors, tells you what lines of code things comes from, like, and like for instance, like even just in like the basic scripts, like the error, like this basically incorporated in all error, it even suggests, things that you might have done wrong when you run a code. Now, a lot of this can be solved if you have a good IDE like RStudio or something like that, but um, for sometimes, you can't use that kind of stuff. And like I find the error handling to be much better in Python. Environments are a huge thing. So like this is why I think many people use Conda. I mean, you can use these things called virtual environments in Python, but what you can do is in Conda is that you install Python and all your packages. But then what you do when you start a project is that you make a new environment with whatever version of Python you have that's like at least, it can be anything with the current version or below in your Anaconda distribution. And then you just use whatever Python, you can put whatever packages in there, and then that's just saved in a whole nother special spot. Then if you have another project, you can then make another Conda environment. And then so all of your environments are like siloed from each other. So say if you want to update, matplotlib in one thing, it won't just break other code and updates in any of the other things. It just like really keeps your environments like separate and understandable. R really, it has something. I've been using something called RENV, like R, I don't even know how you say RN, but it's good and it's getting there, but not many people in R use it. So there's not like, whereas like if I Google anything about like how do I do this in Conda, how do I make this Conda environment, how do I do, like there's millions of responses out there. Whereas if I try to Google stuff about RENV, there's not that much out there because not that many people use it. Because this kind of making sure your code and your package versions for whatever project you're working on doesn't spill into other projects doesn't really seem to be a thing that is as well robust and thought of as it is in Python. And then the last thing is like if you work in a lab, for instance, like you can use Python to control devices. Like I remember in grad school, we use it to like turn a shutter on and off of a camera when like a laser diode did something. So I don't know, that might be, I don't do any of that kind of stuff anymore. But I remember that's, like Python, you can do a lot more different stuff like that with it. But again, both are super useful and in demand. And so they're both good to know. So I guess right here, before we go into like the kind of the tutorial of walking through some code. Does anyone have any questions about Python, personal use cases of why would you want to use Python, how to use Python, at a more kind of like higher level? I guess, yeah, I guess I did have one more slide. So these, I just gonna leave these up here. So if you have the thing, these are like tutorials. There are thousands of tutorials on how to use Python. The basics of getting it started and installing packages and stuff. So these are just some of the ones that I had used when I first started using Python. And then also, when you use these things, regardless of the tool, getting help really is just like Googling a lot of stuff. I mean, I've been coding for 15 years and I pretty much don't do anything where I don't Google code constant. Like questions about if I'm just writing new code, I will be Googling something. And things like Chat GPT, I don't really personally use it at all yet, but like I know some people who have and showed me some stuff where you really can come up with an idea and then get it into code. And so that could possibly be a big way to lower the barrier to getting into a new language, is to just to have Chat GPT write something that mostly gets done what you want, and then you try to figure out what it's doing. And then GitHub, there's always issues specifically on packages that you want to care about. You'll find answers to like why a specific package might not be working on their GitHub issues. Yep. So I guess, yeah. So if there's any questions, I might stop sharing and get this other thing set up.
There was a question. Somebody wanted to know if you could share the websites for the packages that allow you to run Python code in R. I think you're muted. Or are they on your slides? Because if that's the case, I can just share the link to get your slides.
Yeah, I think, yeah, the links to the two packages that you can run Python, and they're on the slides. But I can
Okay, perfect.
copy
So
them and
I will share the link, everybody, to the OneDrive that you all should have access to, but I will share it, and it gives you access to all the materials for all the sessions, so you can get access to the slides that Chris presented.
Okay, so let's see here. So let's see here. Let me start sharing my screen again. Okay. There should be like a blank screen right now. Okay, so what we're going to do is we're just going to start. Where's my mouse at? There it is. So we're just going to start up a Jupyter Lab and then start walking through a notebook. So in Python, so this is assuming what you've done is you've gone through Anaconda and clicked the download button and then downloaded it and then like followed all the prompts, and now Anaconda is on um, your computer. And then I then went ahead and I created a whole new environment just for packages that could be included in this tutorial. So what I do is I just type conda activate data week. And so now, so now my conda environment is only going to look at packages. My Python will only know about packages that are in this conda environment. And then I go to, see the desktop data week. And then inside here, inside this folder called Data Week, there's these IPython notebooks. And so I'm just going to type Jupyter Lab here. And then what that does is that it launches in my browser a way to run the Python code using Jupyter Lab. Takes a second here. Okay. And so what we then do. So this is what so this whole thing right here now is what I was referring to as an IDE. So what you can do is you can have like the terminal here. And so you can have like a terminal access while you're there. And then I'm going to open this. And then, you can have these set up as tabs. You can drag them and drop them, however you want. Sometimes people like to have the terminal open at the very bottom to do some things with. I'll probably just get rid of that for now. Okay, so for this tutorial here, we're just going to walk through just some basic functionality of how to look at some biomedical data. And in this case, it's just an gene expression data set. So the first thing to go over is that this analysis, like this, IDE, these IPython notebooks, what you can do is you can write, both text and code. So these notebooks here. So if I click on this, you'll see this so if people don't know what Markdown is, Markdown is this like pretty popular thing now that you can write certain characters and it'll format your Word doc, your text in a certain way. So if you had this like one little hashtag thing here, it makes it like the title case. And then here, there's nothing here. So it just gives you this. But if you make these little dash things here, it highlights them in a certain way. You can bold, you can underscore or underline and things here, but it's just basically some kind of way that in your code, in your report, that you can have some easier way to read text, but then also have snippets of code that you can then run. Okay, so the first thing we're going to do when we're going to do anything in Python, this is the same in R, is that we're going to import things. So I'm going to run this line of code here. You can see that it's running by this little star here. Now there's an interesting way of the importing things is done in a few different ways. So there is a way of the standard way of importing a Python library, especially like these really major ones, is that what you do is you import the package name, but you import it with a shorthand. And so like pandas is always referred to as PD, Seaborn is SNS. You can change these to be whatever you like, or you can just remove this. But typically you import it as kind of a shorthand. And then what you can also do is you can take a whole package like scikit-learn, and then inside that package, that package can have separate modules of functions. So then you can have this linear model module, and then you can import just one single function from it. And so there's different ways of importing things. And what's really nice about this is that you kind of always understand where your functions are coming from. We'll look at that maybe in a little bit. So for this gene expression data, what we're going to do is it's a URL that has some data. Let's see here. Let's see if I can make this bigger. Okay. Hopefully that's easier to see for people. We will, so this is just a zip file. So in pandas, you can just, read in a CSV. Pandas is, weird in some respect that the function is called read CSV, but then you specify how the file is delimited. So even though it's like a TSV kind of file, it's tab separated values. The function is just called CSV. And then you can use, it's gzip. So this will unzip it. But what you notice here is that you use pd.readcsv. And then you do this, and then it's doing it. So what this PD thing really does that I think is much more intuitive than what happens in R is that in R, you just load the library name for the most part. There are ways of not doing this. There are ways of doing this in R, but no one ever does it. So what happens then is if I go and make a function called a really dumb function. Oops. called read CSV, and then it's going to take two variables, A and B, and then it's just going to return A plus B. I don't know why you would name a function like this read CSV, right? But that is not the oops. That is not the point here, but the point is there's now another function named read CSV. So if I want to go to read CSV, if I do pd dot read CSV, A and B, I'm going to get an error, right? Because what this is using, this is calling the pandas function read CSV. And then, but if I do read CSV with nothing, it's going to call my function because my latest function overwrites anything else that might be named read CSV in base Python. And then I do A and B. Oh, no, what do I do? 2 and 3 or something like that. And so it gives you this. I just want to mention this because this is one of I found the most complicated things of or one of the nicest things about Python is that in R, you'll load a bunch of packages and then you'll get some kind of crazy message at the end that says this select function is now no longer used in base R. It is tidy versus select function. But then you just type in select and you have no idea unless you memorize that message from before, like which actual package you're calling a function from. Because there's something called namespaces, and like ours, the namespaces just collide with each other, and it just takes the last thing that was imported as the namespace, which you can do in Python too. It's just like Python has this like great ecosystem for not having that happen. So it's just like one way of like one reason why these imports are slightly more complicated than something like just as opposed to just like import pandas functions, all functions into the space. Okay. So then the next thing to do, so if we now, what we notice here is that we just assign this thing a variable name. So this whole entire thing that comes out of here is like a data frame object. So it's not like a number. So it's like this whole entire, what we will see is like data frame. What we can't really see is like, but it's like a data frame class. So because what you want to do, if you want to extract, like, say, the first 20 rows, what you do is you do something like you take your variable and then you type dot head and then 20. And that will get you the top of the data frame. But note that this is not a thing that works. Right? Because Panda has no attribute head. There's no function in the whole entire Pandas handling thing that just takes the head. It's not an actual function that is called on something else. What you do is you have a object, and inside that object lives internal functions that you can then use to pull out parts of that data. It is a bit confusing, but this is like, I think, a good example of like where like, because when people start going into Python from R, this is like some of the things, the most things I've heard complained about. It's like, why can sometimes you do like a function on something like, and like NumPy is like the Python numbers package. So you can do NumPy dot sum on a array of data numbers and you'll get an answer. But you can also take that array of data and do dot sum. Um, and it's just is like when you see things coming out of the back here, it's because you're pulling things out of the class itself. But then basically the rest of this is, like how do you subset data frames? Like, can you take a subset of this data? You can. You just take, like your 6th through 12th columns. This iloc is like how the function that you basically like, I want to take these rows. It's like the integer of the locations of these rows and columns. And so you can um, subset your data that way. Yeah, and so I guess the rest of this um package here is just like, so that I guess to explain here too, also there is a student's version of this, and then the instructor version. The instructor version has all the answers filled in. So if this is something you want to try on your own, you can try the student version, try whatever code you want, and then check how it was done in the instructor version. Is there a question?
Yeah,
Yep.
I have the files there that you have listed on the left. What I don't have is the environment in which you are viewing those files. How do you get there?
So yeah, so I guess this is like the environment is something that you kind of have to install on your computer. So that was like kind of like out of the scope of this whole entire class, is like actually getting Python installed on everybody's computer and making sure that they have the right packages installed. So I guess, do you have Python at all installed?
I do. I installed it from python.org from the link.
Okay.
But I really don't even know how to launch. I mean, let's just assume I know nothing. I don't know how to launch Python to get where you're at right now, where I have
Yep.
the ability to open those files, those IPY and B files.
Yeah, so if you installed it from just python.com, um, um, yeah, so I guess like to find out like so this is like also like usually in general now, if you have, especially if you have a Mac and a Linux, what people end up having is like a bunch of different spots for Python on their computer. So if we go to, let's see, how do we can get back there? Let's see here. Kernel, how do you get back to the file? Okay. So there are commands that you'd have to run on your terminal to kind of find out which Python version that you have. So one of the main ones is you do type in which Python, and this will tell you kind of where your Python is. So right now I open up a new terminal. So I'm in my base Anaconda. And so this is telling me the exact location of Python that is going to be used. And so if I then want to activate my Conda environment, I would do Conda activate data week. If I run which Python, like this changes a bit. Instead of it's all in my Anaconda distribution, I just then open this. So now if you, so if you want to basically install, be able to like kind of work in the environment that I'm working in. If you've just installed base Python, I think what you would need to do is if I go to, let's see, Conda activate, Conda 8. Yeah, you would need all of the, like you would need to do, and your thing, since you don't have Conda and you've downloaded regular Python, you'd have to do pip install. So you would have to pip install Seaborn, Pandas, NumPy, Jupyter, and Matplotlib. And those are the packages that you would need to run that whole entire notebook. But this is the main one. You'd have to pip install Jupyter to get Jupyter Lab installed on your computer. Just like you have to go separately to a whole website to download Jupyter RStudio, you could just pip install Jupyter, and then Jupyter Lab is part of it. And then you would just do what I did when I first started, where you just type in Jupyter Lab and it will launch it for you.
Okay, what is pip install?
So
Let
pip
go.
install is like, so there's two, again, there's like two um main package, I think, managers out there. Pip install is kind of like cran, and you can pip install stuff in Conda too. So I'm in a Conda environment. So environments are like these little shells of code, but Conda will let you pip install something, for instance. So like if I do Conda list, this is going to list all the packages I have in data week. Sometimes this takes a minute, not a whole minute, hopefully, but so like you can see, these are all the packages that I have on there. And you can see like this is where it all came from. But now say I want to add a new package into this environment, but it's not on Conda. For instance, I have written a package, but it's not going to get on Conda. Conda, it has to be pretty significant to get on Conda. But so my package lives in PYPI space, so which is pip install. So what I would do, I do pip install gene plexus, which is the name of my package. I do it, and then it's just going to query this database of packages and then just install it, just like you in R would do, install.packages or bio, like the different way of the different syntax to install from bioconda. And so now if we do conda list, you can see that gene plexus is here, and it also gives you a helpful thing that like this did not come from conda. It came from another spot, and this one, for instance, came from pip installing. So you just, from whenever you create an environment, so if you download just Python off of the website, you're going to have to make sure that you have like Jupyter, because it comes with absolutely nothing else. Whereas if you downloaded Anaconda and did it, you could have just typed Jupyter Lab in a terminal, and it would have made sure. And also, like, I don't know when you download from Python directly, if it actually starts using it immediately. Because I think, let's see here. How do I do this?
Well, I have a window that opens when I launch it.
Okay.
That looks a lot like DOS. If you want to go back that far.
So like, yeah, because like I know in Python, there's like a whole bunch of different like spots for it. For instance, like there's something called like the path. I think there's one called like Python path, but basically like there's these environmental variables that you can set to point to where to look for code. And when you do Anaconda, it sets all those paths for you to make sure that Anaconda is like the most used version of Python. Like it's the first used version of Python. I don't know if that necessarily happens when you download it off the thing, off the website. It's not something I'm familiar with. So you just have to make sure that when you type in which Python, whatever Python you downloaded and where you put it is actually the one that it's looking at.
Okay, thank you.
Is there a way to see all the functions that are embedded into? Oops. Okay. Okay, sorry. Should I go back and answer some of these? What are some of the advantages and disadvantages of using? For the most part, Python, it doesn't matter. They're supposed to be language agnostic. I mean, that's like some of the, some packages that aren't like super great will fail on one thing for another reason. Like there are some differences of when you build the code up. If you have something that's not compatible in one thing or the other, it could fail. And generally, I think the preferred order of just generally like if you want it to work for sure is like Linux, then Mac, and then Windows. And that's, but in general, most things should work pretty good on either system at this point, especially like your basic data analysis pipelines. Think when you get into the things of like possibly like super optimizing GPUs or TPU kind of like crazy stuff, like all that stuff is written by like, I think Linux computer people. So it's, it works for sure on that stuff. So after we download the Anaconda, like how should...
Yeah, I think you already answered number 2 because
Yeah. So you
so
can,
I think
it
number
depends.
3.
I'm not 100% familiar with like Mac, I mean with Windows. But Windows has a terminal or like a power bash or something. But in Mac, you just open up a terminal to get it to run. Yeah, so is there a way to see all the functions that are embedded within the object? You know what? That is an excellent question. Um, so this is, I guess, where it also goes to, um, like, does it actually, like, this is like in the practicality sense, like, does it actually matter? Because, like, for instance, if I wanted to, like, like, find the first 20 rows, like, when I say pandas, like one, there's a bunch of different help here. And then like, the function it's, like it's not really a function, but this just then tells you, how to do it. But to get like a list of every single thing that's in a pandas data frame. I mean, I think if you go to, yeah, like I think if you just go to pandas, pandas will list everything that pandas can do. So I don't know if that answers the question. Um, of, can you see everything? I mean, the idea is you can see everything because you can look at the source code. Um, let's see. This is a better formatted one, right? So you can like, show the source code about what it's doing. And then this is like basically all of the stuff that you can, like this will tell you exactly what this function is doing. Um, but yeah, like if you go to pandas, I mean, I imagine there's ways to get in there. Yeah, yeah. I mean, there's just like hundreds so I don't think there's just like a list because there's like hundreds of functions type things that you can call from pandas. So I think like if you want to go into plot, you have to like go into plot to see like all the things that you can call out of the plotting functions. And then I don't even know what an Andrews curve is. But then, you can go see all these things. But pandas has like, I think, pretty good documentation. Um, I just don't know if there's like a full-on list for it. Okay, so it is 3.
So we actually have two other questions. For some reason, it's not allowing people to message to the big chat, and so it's being messaged to me.
Okay.
So the first one is my understanding is that Python environments are completely separate, as in you have two projects in two separate environments that need the same package. You would need to install it twice in both. Do you know if there's a way to optimize since you would be installing the same code multiple times, taking up storage space? Or is there no way around it? Thinking about large packages that take up a ton of storage.
Okay. So that is like a great question. I don't 100% think that I could be wrong on this, but I'm not 100% sure that's true that you actually have to install things in multiple packages if you're using Conda. Um, I think they are smarter about it. And I think because like the idea is like Python virtual environments, you just have Python and then you go into each virtual environment. And maybe that does it too. But what you can do, I think what happens under the hood actually is like when you have, say you download all of Anaconda, you have every single one of the packages there. And what you do is when you add it to another conda environment. I think if it's the latest exact package that's already found, it just hyperlinks it to the already compiled like version of it. Like it doesn't necessarily copy it to its space. I think at some point it is like just like puts a link in there to say like if you're looking at this one, then this one. But if it changes at all, then it does. I think that's the way it works. Um, but I could be wrong. I could be completely off on this, and it literally has to like install everything, completely and then do all the binary stuff. But I'm pretty sure it just links. I know our environment does this, for sure, because it says linked when it's already if you're going from one R environment to another in this RENV package, it'll just say like it has all of the packages pre-installed for all the versions and stuff, and it just links to that version.
The person that asked that said, thank you. We have another question that says, are there advantages/disadvantages to work out of Jupyter browser versus localhost?
Um, guess I don't quite know what the difference is. Um, I guess I am in localhost now. So I guess is that person saying like an actual desktop application, like a standalone desktop application? I don't think exists for Jupyter Lab. I think like their way of doing it is it makes you use your browser. They don't actually have a I think there is something that someone, but it's not run through Jupyter. It's like through something else that you can download an IDE that's basically Jupyter Lab. I think there's something like that out there now. Um, but if that's what you mean, I guess then yeah, I don't think there's like a Jupyter sponsored desktop application. Like you always kind of have to run it through this local host thing.
There used to be like a for Anaconda, like a desktop app for that you could, that's like a desktop sort of
You
like what you could do with like R, and then you can access Jupyter from that. It's been a while since I used Python, but I feel like I remember something like that when I took the
know, there
class.
was something from what I remember a few years ago called Spider.
Mm,
That was like the thing that was trying to copy R Studio, and it was like or Matt. Like this at that point, I didn't even really know what R was. But it was trying to copy not MATLAB. Like MATLAB and R Studio to me are like very similar kind of working environments. And that you can see the variables and like what the types are and like little things about their data, and then like I think Spider was something like that, but it was just really buggy and slow. Um, but I don't really know a lot about IDEs, to be honest, because I don't ever use them. I code in on high performance computing cluster things, and lots of them don't have really great, interfaces. So I code in like Vim. If people are familiar with that. It's, just like this really awful Linux text editor. Um, so I don't really know like all the intricacies. I know Visual Studio people love, and it's like ubiquitous. It can use like you can use it for like any languages. So I know a lot of people who do like a lot of programming use that. Right.
awesome. Are there any other questions?
Yeah, so I guess the rest of the notebook wasn't too, it was just kind of going over some manipulating some data, trying to show people that you can do similar stuff that you can do in R, and then making some plots of stuff. But there's again like hundreds of tutorials that do that kind of stuff.
Awesome. So just to let everybody know, I put the attendance link in the chat, so please complete it. We want to hear your feedback. And then, yeah, are there any other questions for Chris? If not, then we will see you at the next one.
Let me
We
see.
will stay on until, just in case people want to stay on and ask questions after everybody leaves. That happened to me yesterday. Do you guys have any questions?
How'd yours go yesterday?
Good. So
Should I stop?
sorry.
Should I stop recording at this point, or should we?
Yeah, that would be good. Hold on, I just got an individual. Are you talking about the